And what is inductive effect basically? So inductive effect and why it happens, just quickly we can summarize. And how it arises. Okay, what's the reason for inductive effect? So I hope you're getting my point. Yeah. So quickly just tell me what is, how it arises. It arises because of difference in electronegativity. Got it? Clear or not?
Yes, sir.
It arises because of the difference in electronegativity between the two atoms. Okay. And the electronegativity difference causes the electron cloud to get shifted in one direction. And that results into partial charges on the constituent atoms, which are bonded to each other. Clear or not?
Yes, sir.
These partial charges get transferred throughout the molecule by the sigma bond, because once the if one atom acquire partially positive charge, because chlorine is attracting, it's trying to pull away the electrons from it. That atom, carbon atom, will attract the electrons from other carbon atom, and that other carbon atom will attract the electron from next one. Okay, and so on. So it can go up to 4 bonds. Clear? Because
Yes, sir.
and it is a very weak effect. Okay, after 4 bonds, it is almost nil. So this, I hope, is clear to you. Got it? Next
Yes,
is
sir.
okay, and it brings charges, and it is of two types. All the effects are of two types. Okay, plus and the effect is represented by its alphabet, and it is plus sign is put and negative sign is put in front of it. Okay,
Okay.
plus means the one who is giving electrons. Okay, is it clear?
Yes, sir.
So one who is giving electrons is plus, and one who is pulling, withdrawing, is minus. So the Cl is exerting minus I effect, as you can see here. Okay,
Mm.
and the alkyl group is exerting plus I effect, right? So basically you have plus I and minus I effect. So this we have seen, and how they affect. Okay, what's the mostly the electronegative elements like chlorine, bromine, iodine, okay, oxygen, and they exert minus I effect.
Mm.
Clear?
Yes, sir.
And the alkyl groups or the negatively charged groups, okay, they exert plus I effect because they are not electronegative.
Mm.
And this can cause the bond polarity. Okay,
Mm.
is it clear? This can bring the polarity in the bond. And bond polarity, polar means the separation of charges is taking place. Okay. So bond polarity, we consider that arise because of the electronegativity difference or because of the inductive effect. Okay. And if all the atoms are same, such bond will be called as a non-polar bond, as you can see here. And if there is electronegativity difference, it is called polar bond.
Okay, sir.
How a polar bond is going to break and a non-polar bond going to break.
Equally.
Polar bond means actually one atom is trying to pull the electron, and when they break, that atom, electronegative atom, which in this case is B, will take away both the electrons along with it. Okay, this is represented by an arrow starting from a bond and put towards the B. Got it?
Mm.
Similarly, if it is a non-polar bond, then the both the depart when you give heat or light, the bond will break. And how will it break? It will break equally. Equally means the electrons which are part of the bond will separate. Okay, equally. One electron is taken by each atom. Is it clear?
Yes,
Okay,
sir.
got it. So this is homolysis and heterolysis, right? So we can take some examples and let's say suppose if I take this is cyclohexane and chlorine,
Mm.
how the electron will be shifted in this towards which atom is responsible for the shifting of electrons and in which direction they are going to get shifted.
It will shift towards chlorine because if chlorine pulls the electrons,
Hmm. Yeah.
so it will be negative.
So it is going to start from the carbon chlorine bond, right? Absolutely correct. And this carbon chlorine bond, chlorine being more electronegative, will pull the electrons towards itself. Okay.
Mm.
And chlorine will acquire partially negative charge. It is not Cl minus like there in the NaCl because it is the bond is still there. It's not completely cleaved.
Mm.
And this because but if the chlorine is pulling the electrons, who is giving the electrons? Is there anyone who is letting its electron being taken by chlorine? It is the carbon. Okay. So this
Yes.
carbon will acquire delta positive charge, right? Because it is
Yes,
the
sir.
one connected to chlorine. Then the other nearby carbon atom will also acquire delta dash positive means delta dash I am putting just to represent that there is positive charge but less than the one which was directly connected to chlorine, and that is obvious, right? Then
Yes,
again
sir.
delta double dash plus. Got it?
Yes, sir.
So where the positive charge is going to be least? Which positive charge is going to be
Mm.
least? This delta
The
triple dash.
topmost.
Yeah, that is at the opposite one. This one, it is least. Why it is least?
It's the farthest away from.
Yeah, it is the farthest away. It is a very weak effect which decreases drastically with the distance, and it is almost nil after four bonds. Okay, clear?
Yes, sir.
Okay,
Yes,
now,
sir.
now so this is how it is happening. Just you need to decide who is more electronegative, less electronegative. Okay. In homework, you can try your problem 12.14 and 12.15 from your NCERT, right? That will help you out to understand this. Okay. Same, we have already covered that. Okay.
Okay, sir.
Suppose if you have, let's say, Cl and OH, how the electrons are going to get shifted. In each bond, we have to see. Oxygen is more electronegative, so bond will be polarized towards the oxygen. H will have delta positive, O will have delta negative. Got it? And between oxygen and Cl, though
Yes.
both are electronegative, but oxygen is more electronegative. Getting my point?
Mm, yes,
Oxygen
sir.
is oxygen is more electronegative. Okay. So oxygen will pull the electrons from Cl also. So Cl will have partially positive charge, but in this case, carbon and chlorine was more electron. The electronegativity order is like this. Clear? So oxygen is more
Yes, sir.
electronegative than chlorine. So this is how the electrons get shifted. Okay, this is a permanent effect. These three are permanent effect. There are other effects which are temporary effects. Temporary displacement of electrons. So temporary displacement of electron of a double bond or a triple bond. Okay, they can occur. Is it clear? Uh, Due to the attack of an electrophile or a nucleophile. Okay.
So what do you mean by temporary displacement?
Yeah, just I'm explaining. Temporary displacement of electron of a double bond can occur due to the attack of an electrophile or a nucleophile.
Does temporary displacement not take place in single bond and triple bond?
No, this was all this which we were discussing. That was permanent effect. Inductive effect is a permanent effect. Is it clear?
Yes, sir.
Getting my point or not? Why it is permanent effect? Because it is not because we are discussing the Cl is having the negative charge. It will always have that negative charge on it. Clear?
Yes.
And the positive charge because it is always electronegative. So not because of our discussion that negative charge has come up. Okay. So it was a permanent effect. Inductive effect is actually a permanent effect. Is it clear? Temporary
Yes.
displacement of electron can also happen under the presence of some external reagent. Are you getting my point? Temporary mean that is not permanent, that is not that is occurring because of the presence of some other group. Okay, is it clear? So how it happens, let me explain. But this is a very important thing. If you can understand this, you can master all the reactions of organic chemistry. Are you getting my point? So what is an electrophile? Generally it is represented by E plus. It is known as electron loving species. It is it is example like H plus, NO2 plus. Okay, these are the substances. CH3 plus. Getting my point?
Yes.
Yes, sir.
These are the substances which are electron deficient, and wherever they go during the reaction, they want to have the electrons getting attracted towards them. Okay. Nucleophiles are the species, nucleus loving species. So, which species can bind to the nucleus? The one who carries extra electron. So, electrophiles are electron deficient species. Got it?
Loving species.
Electron deficient means
Electron loving species.
electro yeah electrophile are electron loving species. Yes. And why do they love to accept electron? Because they are deficient, because they don't have electrons. Got it? I hope this is clear. Because they don't have electrons, that's why they want to get electrons from other molecules. Is it clear? H plus, NO2 plus, CH3 plus, X plus, which can be halogen plus. Okay, there can be neutral electrophiles also, which do not have complete octet, like AlCl3. AlCl3 is having 6 electrons. Only 3 bonds are there. BF3. Is it clear? The octet is incomplete and they want to accept electrons. Some are positively charged, some are the one which do not have electrons in them. Okay. Nucleophiles are nucleus loving species. Nucleophiles carry lone pairs. Okay, they can share their electrons. Okay, like H minus, CH3 minus. Okay, so CH3 plus and CH3 minus, you can see. Is it clear?
Yes.
OH minus, X minus. Some can be neutral also, which carry lone pair, which they can share with other groups. Okay. Is it clear or not?
Yes.
So electrophiles and nucleophiles. Water is also nucleophile. But OH minus and water, who is stronger nucleophile? Who is stronger? The OH minus, the negatively charged, is going to be more stronger nucleophile. Got it?
Yes, sir.
Why the negative charge is going to be more stronger? It's negative charge is actually more reactive. It can give its electron more easily, right? So,
Sir,
hmm.
can you explain nucleophile again?
Yeah, nucleophiles are the neutral molecules or those species which carry extra electrons or lose electrons, which they can share with other molecules. Got it?
Okay.
Like NH3 is a nucleophile. Is it clear?
Yeah.
OH minus is a nucleophile. Br minus is a nucleophile. So when they react, what they will do? They will share the nucleophile because they have extra lone pair of electrons with them. Is it clear? So nucleus loving species, electron rich species are known as nucleophiles. Electron rich. And any molecule which is rich in electrons, it can lose its electron, it can give its electrons. Got it? While it can offer its electron to some other molecule to form bond. So these are electron donating species. This is different from inductive effect. Inductive effect, we were not talking about a chemical reaction of two different molecules. We were talking only of the one molecule. A part of it was actually electronegative. Okay, but this is regarding when the reaction is happening with external reagent. Okay, so let me make you understand the electrophile and nucleophile by giving actual examples of chemical reactions. Let's say, suppose if I write this molecule, which molecule is this? This is ethene.
Carry so nucleophile.
Yeah, this is ethene. Yeah, and this carries some pi electrons. Okay, pi electrons, of the double bond are not more tightly held like a sigma bond electrons. Okay, sigma electrons are along the line joining the two atoms. The pi electrons are formed by sideways overlapping of p orbitals. Okay, and suppose if I react with H plus. Okay, H plus can come up from any acid, right? So how the
Yes.
reaction is going to happen between them? How should we progress? How should we proceed? How the reaction is going to happen? I hope you are getting my point. Okay, how the reaction is going to happen between them? So as the H plus is, so this is not a permanent effect. First of all, we are not discussing a effect which is present within a same molecule. We are discussing two different molecule. When the H plus is coming closer to this, what will happen? What will happen, Maha, Nabila? It will try to get electrons. Okay, what it will do? It will move towards the source of electron, lose electron, and where the source of electron is, this double bond is the source of electron. Okay,
Okay.
so what will happen? These two electrons are there after double bond. Okay, H plus is coming like this. Okay, this my hand is H plus. Okay, can you see this H plus?
So
Does
you
this carry?
saw.
Yeah. Does this H plus carry electrons? Its own electron. Is it electron deficient or rich? H plus. It is deficient. Okay. So if it is approaching a double bond, what will happen? Can you see? It will break the double bond. It will pull the double bond towards itself and will try to get the electrons from the double bond and will itself form a bond. Is this clear or not? And that pair of electron movement I have shown by arrow. Is this clear? I hope. Nabila, Maha.
Yeah.
Look, this was the double bond. Two bonds are there, okay? This not sigma bond remain as it is. This is the pi. H plus is coming like this. Okay, this is the H plus. This doesn't have electron. So what it will do? These pi bonded electrons will get attracted towards the H plus, and this H plus will form a bond with the carbon. And these two electrons, this is my pencil which is being shown. These two electrons were actually part of a double bond earlier. Okay. But now they are connected to H. Can you see it? I will just show it to you by diagram also, by writing it. So these two electrons are now here, okay, and there is a plus charge which will develop on this carbon. Why the plus charge is developed on this carbon, and why what these arrow represent? This arrow represent movement of a pair of electron. The electrons are in the double bond, and arrow head represent where the electrons are going. Maha and Nabila, is this clear? This technique
Yes,
is
sir.
known as curved arrow mechanism.
So why is the plus over there?
Yes, I am coming to that. Curved arrow mechanism. Whatever I am saying, silently I can depict everything by putting arrows. Is this clear or not?
Yeah.
Yes, sir.
Curved arrow mechanism. Okay. Why the plus charge is on the carbon? Look, by pulling this pi electron, okay, by pulling this pi electron, H got electron from this pi bond, okay, and now it is not an intermediate. Now it has connected completely to itself to the carbon. It has become neutral. But during this whole process, someone has lost its electron. Are you getting my point? Who is the loser? Who has lost the electrons? If you
Finished.
count then, yeah, this
The
carbon.
plus.
Yeah, this is the carbon atom, okay. Not this carbon atom, because this carbon atom is already still making four bond. Earlier it was making a double bond with another carbon atom. Now it is making, instead of that double bond, it is making that bond with H. Getting my point?
Yeah.
Yes.
So wherever that plus charge is appearing, that is the carbon which has, because that bond is being snatched away by the hydrogen, okay. I'm talking about this carbon atom on this side, okay. H plus came approached from here and this. So that carbon atom, okay, which was here, that will have plus charge. Is it clear? So this
Yes.
H plus behave as an electrophile or a nucleophile? H plus behave as an electrophile or a nucleophile?
Electrophile.
Electrophile. Because it is positive and it is
Yeah.
electron deficient, so it will behave as an electrophile. Got it? And this double bond has behaved, the pi bond of the double bond has behaved as a nucleophile because it has given its electron. Okay. Electrophile will temporarily um, pull the pi electrons towards itself, and that is known as positive electromeric effect. Electromeric effect is a temporary effect. Is this clear to everyone? It is a temporary effect. Okay. And suppose if H plus is not there, will the electrons of the double bond get shifted on one side? Will they get shifted or will they continue to remain as they were?
So can you repeat?
If the H plus is not there, will something happen to the electrons of the double bond?
No.
Will any? No, nothing will happen. Only in the presence of H plus, this shifting of electron has taken place. These electrons are snatched away by the H plus. Are you getting my point?
Yes.
So this is a permanent effect which is always there in the molecule of ethene, or is it the effect which occurred because of presence of some species? Is it a temporary effect or is it a permanent effect? That's what I want to ask you. Whatever I'm discussing is temporary effect or permanent effect.
Temporary, right?
Yeah, it is a temporary effect. Okay. Exerted by electrophile, so electrophile will snatch away the electrons. Okay, and will get connected to a molecule, to the source of electrons. Okay, electrophiles are just like the magnet. Okay, and they just want to get the electron and get them connected, get themselves connected to the molecule by forming a bond. But in this whole process, some other atom is a loser, and that uh, develops a positive charge. Is it clear? This is positive electromeric effect. Electrophile exert positive electromeric effect. Is it clear? It is only in
Yeah.
the presence of some external H plus. Suppose if this H plus is removed, what will happen? If H plus is removed, these electron will get back to their original place. Okay, so this is a temporary effect, electromeric effect, and electrophiles exert positive electromeric effect. Okay, lot of things we have seen in this. Okay, and whole story is being depicted by putting arrows, and this way, this style is known as curved arrow mechanism. The arrow is put from the source of electron to the destination where the electrons are reaching. Okay, any doubts on this? This is very important. If you can master this, you will have no problem throughout your class 12th organic chemistry. Okay, is this clear?
Yes.
Let me give you one more example, one, two more examples, and we can just try to understand that who is giving electrons, who is accepting electrons. This is carbon double bond oxygen. Okay. Does it carry any partial charges or not? or it's absolutely non-polar? How will you say? Does it carry any charges or it's absolutely non-polar? Carbon oxygen bond. Who is more electronegative? Hmm?
Oxygen.
Oxygen is more electronegative. Yes, absolutely correct. And this is the inductive effect. Oxygen is having minus I effect, and this will have plus I effect. Okay, that is a permanent effect within the molecule. That is not electronegative effect. Okay. So this is the picture of the molecule. Okay. And now I react this molecule with H minus. This is electrophile or a nucleophile? Electron loving species or
Yes.
nucleus loving species? This one.
Electron loving.
It already had carrying its own electron and negatively charged, so how it can be electron loving species? Got it?
Okay.
Because it is already having negative charge, okay, and full of electron. I have shown the electron in the form of a lone pair, so it cannot be electron loving species. H plus was electron loving because that was not having electron, it want to have electrons, some electrons. It is already having more electrons, more than what it can hold. That's why it is minus. Okay, so when it reacts with certain molecule, what do you expect? You
For
expect,
it to attract
yeah,
electrons from the
you expect H minus to accept electron from any other molecule or give its electron to be shared to some other molecule. It is full of electrons.
to
Will
give.
it? Yeah, it should give its electron for sharing. Nabila, is this clear? Will it
Yes,
accept
sir.
or will it gain? Give its electron. It will give its electron. Got it? Because it's already having this extra pair of electrons, so how it can accept more? Okay, it cannot become more negative. So okay, it want to accept electron, but so it is an electrophile or a nucleophile? What should I write now? Electrophile or a nucleophile?
Nucleophile.
Yes, this is a nucleophile. Correct. Nabila, is this clear?
Mm. Yes, sir.
So, to which atom will it share its electron? You have some other molecule or double bond, or is it the oxygen or the carbon end to which it will get share its electrons?
Carbonate.
Yeah, the carbon. Why? Because the carbon is oxygen is negatively charged, partially negative. So if
Carbon
H
is positive.
minus, yeah, positive, so it will get attracted. I will put the arrow. Got it. The carbon is making four bonds. Is it clear? So if it is making four bonds and if the H is coming and giving its electron, can it make five bonds? Can it make five bond, Nabila? Maha? If the H get connected, how many bonds carbon will have? If the H minus also get connected to CH2O, total how many bonds it will have?
5.
Yeah, five. But five cannot be there, okay? Because carbon is second period and it has 2s and 3 of the 2p orbital. Only 8 electron, only 4 bonds are allowed on carbon. Carbon is tetravalent. Got it?
Yeah. So how many
Yes.
bonds are?
So what to do? We need to make some space for those
You can break
incoming.
one bond. Right?
Yeah, one bond. Pi bond is going to get shifted. And that is in favor of oxygen. Oxygen want to have this electron completely on itself. Okay. and that carbon is getting electron from the edge. Nabila, are you getting?
Yes.
So this is acting as an electrophile. An electrophile cannot work in isolation, it needs a nucleophile. Okay. Similarly, a nucleophile also cannot work in isolation, it wants an electrophile. Got it? So, okay. And the whole thing can be silently depicted without saying even a single word with the help of arrows, curved arrow mechanism. Is it clear or not? You must be able to read these arrows. Okay, they tell you everything. Is that clear? So right now we are discussing these many things in detail, right? But in class 12th and by the end of class 11th, you will be quite confident with the arrows. You will automatically be able to write all the reactions and the mechanisms. Okay, with complete confidence, right? Got it?
Yes.
So now there the H plus was there in the above case. Look how what compare the difference. There the arrow was put towards the arrow head was put towards the H plus because H plus was getting electrons. And in this case the arrow head is put away from H plus because the H minus because the H minus is the giving its electron. Got it? Is it clear? So
Yes, sir.
CH2 I have connected it, okay, and this is O minus. Remember the charge should remain neutral. Charge should be conserved, okay. So initially H was minus and CH2O was neutral, so overall minus charge should be there. Is it clear?
Yes.
Yes, sir.
So this is the nucleophile. Nucleophiles will whenever they go and approach a double bond, they will push away their pi bonds. Okay, on the next atom. And if there is an electrophile, that will pull the pi electron towards itself. The nucleophile will push the pi electrons away from the double bond onto the next atom. Got it? I hope this is clear.
Yes.
Electrophile and nucleophile. Okay, so nucleophiles, this effect is temporary because it is observed only in the presence of H minus. If H minus is not there, no such shifting of electrons will take place. Got it? Clear or not?
Yes.
No such shifting will take place. So this is a temporary effect which is caused by electrophile or nucleophile. Electrophile will cause positive electromeric effect in which while getting bonded it will pull the electron of the pi bond, while the nucleophile will exert negative electromeric effect while getting bonded it will push the pi electron away from the double bond. Got it? Is it clear or not?
Yeah.
Okay, so this is I will write nucleophiles will show negative electromeric effect. This electromeric effect need to be considered only when you are dealing with two different molecules, okay? Not with the one molecule. Got it? Is it clear? So this I hope everybody understood. This is very, very important. Any doubts you can tell me, I will explain it again. Got it? Okay,
Sir,
so
can you explain that electromeric effect, like definition? What?
electromeric effect is the temporary shifting of electrons of a double bond in the
Okay.
presence of electrophile or a nucleophile. Electrophile pull the electrons towards themselves, and they are said to exhibit positive electromagnetic effect. On the other hand, nucleophiles push the electrons because they themselves are having their own electrons. So why they will get more electrons from the double bond? They will not get. They will push the double bond. Got it? Is it clear or not? So negative electromagnetic. Okay. This is how we are going to show. So what we have learned in this part, okay, we have learned today uh, inductive effect. Inductive effect is a permanent effect. Okay, that is there as long as these groups are there. Okay, that shows how the electrons are shifted in a molecule. Okay, it's not because of some other external factor. It is a permanent effect. Electromagnetic effect is a temporary effect, and this is exerted by some other electrophile or a nucleophile which is approaching a double bond. Electrophile will pull the electrons of the double bond and will show positive electromagnetic effect, while nucleophiles will push the double bond on the other atom and will show negative electromagnetic effect. Got it? I hope this is clear to you. Okay. Right. So now we are going to, and we learned electrophile also. What is an electrophile? What is a nucleophile? That also we learned. Okay, and this thing which we learned is going to be the form the heart of the organic chemistry. So be careful. If nothing is clear, do tell me. Right, Maha Nabila, just have a look and tell me if anything is not clear, where I have put what charges, how I have moved the electron, what number of bonds I have put. Okay, be very clear. Okay, shall we proceed?
Yes.
Okay, good. I will give one more example of electrophile and a nucleophile, but that doesn't show, that is not an example of electromagnetic effect. That is only then an example of an electrophile or a nucleophile. Okay. This is an ether, methoxymethane. If we recall the IUPAC name, what will happen if it is put into acid which contain H plus? And what are these? These are unshared pair of electrons, lone pairs.
Hydrogen will be added.
Yeah, in this case, the lone pair which was unshared and lying ideal, and that will be shared between the oxygen and the hydrogen. Is it clear? So this is a nucleophile. Navila, is this clear or not? And this is going to be an electron, right? So what will happen after that? But there is no double bond, so this is not an example of electromagnetic effect, but this is an example of an electrophile and a nucleophile, CH3. Now the oxygen is left with only one lone pair and a positive charge because the positive charge is taken away from H plus. Okay. Is this clear?
Yes.
Yes, sir.
Okay, good. So now we are going to discuss another effect. So temporary effect is only electromagnetic effect. Okay. And that too happen whether you have electrophile or a nucleophile in the presence of that. Okay, then you have resonance effect. Or mesomeric effect. This is depicted by a letter M or R. Okay, so first we need to understand what is resonance. Okay, and what it means, and then we can discuss its effect. Okay, how it affects the displacement of electrons within a molecule. So what is resonance? Maha and Nabila, just you can try to explain it to me in your own words. Hmm. Any idea about it?
I thought
No,
resonance meant the quality of being.
no matter, it can go wrong. Okay, so don't worry about getting it wrong. That is not a problem at all. Okay, sometimes the things get absorbed more efficiently if we make a mistake. Got it? So that is very, very important. So what it is basically? Tell me. Hmm. So we
I
can write.
heard about resonance in like novels and stuff and describe the beating of the heart in a room.
It describes the.
Beating of the heart, like the sound coming out.
And it is there in the physics also. Okay, right. And it is there in the chemistry also. So in chemistry, what it means? Okay. So and suppose if a vibration is happening and somebody is hitting that with something hammer or something, and that vibration is happening, and the frequency of hitting by hammer is matches with the frequency of the vibration, then all the energy will get added up and that thing can break. Okay, and that is there in the sound chapter in physics. Okay, in chemistry it has a very different meaning. Okay, in chemistry actually it represents the movement of pi electrons, lone pairs, within a molecule. So suppose if you have a carbonate you all know, okay? What's the where it is found? Carbonate ion.
In lime.
Yeah, in limestone. So we have Taj Mahal made up of calcium carbonate, okay? That is marble, right?
Yeah.
And in your UAE, you have that very big mosque, okay, recently um, made up of marble, right? That is carbonate, okay, you know. So it has calcium and carbonate as the anion. So carbonate, this is the Lewis dot structure, okay, and somebody may write it like this also. Is it correct or incorrect?
Yes, true.
It's same, exactly same, because all three oxygens are equivalent, so I can make double bond with any one of them and keep the other two as single bond with O minus. Got it?
Yeah.
For turn by turn, I can switch the position of the double bond. Got it? This is the minus. So all three are correct structures. Or is some of the structure incorrect? It's not incorrect. It's just the way in which it is written. Okay, getting my point?
Yes.
So, but when you check the actual structure, it is like this. This is delta minus. Okay. And what this is dotted line represents? What these double line represent, first of all, tell me.
Double bond.
Double bond. Yes. And single line is single bond. But in actual structure, none of the bond is completely double bond. And none of the bond is completely single bond. But all the bond are exactly similar with having partial double bond character. Is it clear or not?
Yes.
So how it may have happened actually? The molecule um, has not chosen to form any one of the structure. Instead, the molecule, the carbon, preferred to form partial bond with partial overlapping with this oxygen, okay, and this oxygen. This is the real structure. This real structure is known as resonance hybrid. This is the real structure, actual structure which exists. Whatever the structure, original structure that were written as per the chemical bonding, as per showing the bonds, complete double bond, single bond. Okay, those are known as canonical structures or resonance structures. Got it?
Yes.
Yeah.
Okay. So whenever you have more than one structures, the actual structure is actually the um, hybrid of all those structures, the average structure of all those structures. These resonance and canonical structures are imaginary. And the molecule has formed a hybrid structure. Why it has formed a hybrid structure? Got it? Because that hybrid is more stable. And hybrid is the actual structure which exists, okay, not the single structures, okay. Because what the molecule adopts is the average of all the structures, because in that average structure, which is the hybrid, the molecule, the electrons are delocalized, better delocalized, they are better distributed. Got it? The negative charge is also equally
Yes.
distributed on all the three oxygen, and that is more stable, right? That's why only the hybrid exists, not the canonical structures or individual structures exist. Okay, is it clear?
Yes.
And the difference in energies, okay, between these imaginary structures and the most stable resonance structure, imaginary structure, and the hybrid is known as resonance energy. Resonance energy is actually the extent of stabilization which has happened because of resonance. Let me take another example, very famous example of organic chemistry only. But it is not the phenomena related to organic, it is throughout the chemistry. Wherever the molecules can be written in different forms, the actual structure is the average of all those different forms. So instead of those individual different forms, only the hybrid exists, right? Got it? So let me write the resonance structure of benzene. Okay, resonance structures of benzene. Benzene is a very famous molecule. All of us know it. Okay, very well. So there are six carbon atoms connected by alternate double and single bonds. Okay, I have not written the carbon atom and the hydrogen atom in the bond line. That is quite obvious. Okay. So this is the benzene. So Maha may have drawn this benzene and Nabila may draw it like this, right? That this is because all sides are same, all carbon bonds are same. So Nabila may have chosen to draw this structure. It is same, they have same number of bond, double bond, single bond. As such, there is no problem in any of the structure. Got it? One structure given by Maha, structure given by Nabila. Okay, both of
It's the
you.
same thing.
Yeah, it's the same thing. Exactly same thing. Only but the positions you have depicted is on one side and other side. Okay, but exactly it is same. The bonds types are same. Okay, right. But when you and this bond length, it is 1.33 angstrom. This is double bond. It is shorter, and this is 1.54 angstrom. It is longer, and either you will make double bond or single bond. That's how you will draw the benzene. Okay, and there is no problem in it. But when we check the actual benzene, Actual benzene is the mixed form of all these two structures, that is known as hybrid. So how should I draw the hybrid? Okay, this is a double bond, and in this case you have at the same position when you compare. Okay, this yellow bond, when you compare, this is a double bond and here it is a single bond. Okay, so in one case it is completely taken as the completely double bond, in another case it is completely taken as single bond. But what the molecule will choose? Molecule will choose to follow the middle path by doing some overlapping, and in the actual molecule it will be the average between somewhere double and single. Got it? And this is how you are going to draw the hybrid. Okay, let's talk about this one, this green bond. Okay, this green bond in this first structure, it is single bond. In the second structure, it is double bond. In one structure, Maha has chosen to keep single bond and form double bond on the other side of this green bond. And in the second case, Nabila has chosen to form a double bond between these two carbons. But what actual bond is actually present between these two? The actual is the average. It is between somewhere, it is not completely double, it is not completely single, some overlap has taken place. So it is between double and single. So one bond is completely there. Okay, the other bond is not completely absent or not completely present. I have represented it by dotted line. Same thing I'm going to do it here also. Is this clear? And this is known as resonance hybrid of benzene. Is it clear?
Yes.
This is the actual molecule which exists. Okay. So, and this is more stable because if all the bonds are connected, the electron can move throughout the molecule and that will create more stability. So because it is a cyclic delocalization of electron by the means of resonance. Why I'm calling delocalization? Because with the joining of these double bonds, the electron can move throughout the ring in a circular manner. So I represent these partial bonds as this. Okay, so this, and how you know whether this is just an imaginary concept or really it is happening? That resonance hybrid is the real molecule, real structure which exists. Okay, and while the resonance structures are imaginary.
So, sir, double bonds don't really exist.
Pardon? Double bond, sometimes if it is a single double bond, means if a double bond is isolated, it will continue to stay as double bond.
So, if there's more than one double bond present, then
Yeah, if
it.
there is more than one double bond which are neighbor to each other, mean double bond, single bond, double bond, mean there is a conjugation. This term is known as conjugation. Double bond, single bond, double bond. So what these double bond do? The middle bond also acquires some overlapping, and that let the two double bond interact through electrons, and that become the hybrid structure, and that's how the molecule attain more stability. Is it clear? And the evidence is the bond length. Okay. In this case, in this structure, all the CC bonds All are exactly equal, or 1.39 angstrom. Got it? So this is the hybrid. But actually we don't write the hybrid. We should always keep it in mind. In notebook or in many questions you will find this structure written, because it is actually convenient for our mind to know where is the double bond, where is the single bond. Got it? Is it clear? If I write like this in first case or in my first class, you will also get confused. I will also get confused that what these dotted lines are. Okay, right? This is actually this the electrons, pi electrons are six only. You can see, but instead of making complete three double bond, they have made partial double bonds. So of the circular manner, that is the hybrid. Is it clear or not? And it
Yes,
is
sir.
more stable. Okay, when you and experimentally you can make out by checking the bond length. All bond lengths are 1.39 angstrom. Okay, when you try to compare it with the energy, this is one first canonical structure. This is second canonical structure. Though both were same, but still the molecule adopted some other structure which was more stable than each one of them, right? So a hybrid is more stable than the canonical structure or the resonance structures. This is resonance structure 1. This is resonance structure 2. And this is the resonance hybrid. It is more stable. Got it? What this gap is known as, by which tell us the extent of stabilization. What this gap is known as, this is known as resonance energy. Difference between the energy of the more stable resonance structure and resonance hybrid. Okay, for the benzene, it is minus 150 kilojoule per mole. Got it? Is it clear or not? So what is the resonance? How you will define? Tell me. What do you mean by resonance?
The resonance, energy and resonance is the same thing.
Yeah, resonance is the, you can define, yeah, energy, it is the stabilization which is caused by the resonance. Okay, got it.
Yeah.
So tell me, what do you understand by resonance and resonance energy? What do you understand by resonance? What some conclusion you can draw? Yeah, with all our discussion. Yeah, tell me.
Like the bonds called double bonds will be connected to each other in a single line inside the molecule with
Hmm.
and it's represented by dotted structures.
Partial bonds, right? Yeah. Yeah. Nabila, would you like to add anything regarding the resonance?
Yes.
It is the delocalization of pi electrons, lone pair, or unpaired single electrons, which are known as free radicals, with adjacent double bond or a triple bond. I will write it here. Okay. So resonance is the delocalization of pi electrons, lone pairs, odd electrons. Clear or not?
It's clear.
Yes, sir.
And it causes stabilization, right? And this stabilization is actually called by the name of resonance energy. Okay. And there is a definition for resonance energy also. How will you define resonance energy?
Difference in the
Difference between the
Mhm.
stable resonance structure and the resonance vibrator.
Difference between the most stable resonance structure and the hybrid. Got it. Clear. That's and what is the resonance?
Delocalization of pi electrons.
Hmm. It can include lone pair also. Okay. And there are groups which can give electrons to resonance. They are called plus R. Okay. Resonance, the groups which can give electron through resonance, which can give the lone pair, they are plus R, and the groups which can pull the electron through resonance are known as minus R exciting groups. Got it? Clear?
Yeah.
Yes.
So Next phenomena is hyperconjugation. So what do you mean by hyperconjugation? What do you mean by hyperconjugation?
Delocalization of sigma bonds.
Hmm. Sigma CH bonds. Okay. With adjacent pi bonds. Got it? Is it clear?
Yes, sir.
Yeah.
So that is called hyperconjugation. It is known by the name of H effect. Right? So I need to depict hyperconjugation. Okay. It is a CH bond with participates. How it participates? With the adjacent double bond, hyperconjugation takes place in alkenes, cations, right? And free radicals can be stabilized by hyperconjugation. How it takes place? This is a plus charge, and the CH bond can get attract the can be attracted by the plus charge. Okay, and you will have this. Got it?
Yes.
Yeah.
Yeah, like this turn by turn, all the H atoms can get involved in the hyperconjugation, and this is also known as no bond resonance. Got it? Clear?
Yes.
Why it is called no bond resonance? Because you see in some of the structures, the bonds are missing. But the actual structure will have the bonds, okay? Because it will be the average of all these structures. It is hyperconjugation is exhibited by cations. It is exhibited by alkenes also. So it can cause the stabilization of alkenes, of cations, carbocations. Got it? To the delocalization of electrons. Clear? So we have seen three permanent effect. What are these three effects which can let the electron delocalize in the molecule? What are these effects? Permanent effects.